Then NFC, spoke about it earlier. Again, in Sri Lanka, it became quite popular during COVID because we did not want to hand over our card, bank card to the cashier and get it back. So they let us place the card near the machine ourselves. Okay, so that is where we used it a lot. The security risks of using NFC, generally these stars in the notes indicate that they are based on past paper mark schemes. So eavesdropping is listening into somebody's conversation. Manipulation or data corruption is you change the data. Man in the middle means you are intercepting data, obviously either to manipulate or to eavesdrop. And encryption is used to protect your data from being stolen. Encryption is something that we will look at again in network security. Then you come to technological convergence. Okay. Previously unrelated technologies that are brought together. So it includes smartphone is the best example where the camera, music players, voice recorders, all of them have been combined. Then a multifunctional printer, which can print, scan, copy, and even send faxes. Faxes again is something that is slowly being phased out, I guess. Surfing the internet on a smart TV, online radio, e-books. You can think of even the Kindle machine that came as a book reader. I mean, then it can, if you can browse the internet with it as well. So it is like more or less a tablet there. Better to get a tablet with which you can do multiple tasks than to get a Kindle which can only be read as a book maybe. So, and game consoles as well. Then IoT is something that you do learn a lot in A2, but when you talk about linking of all these devices together, when you are talking about smart homes, all of them, IoT is the infrastructure there. Any device that can be connected to a network, in return can be connected to the internet, becomes an IoT device. So benefits of technological convergence. This is again from a past paper question, the marathon runners question. So this is how they will ask a question. They will never ask what are the benefits of technological convergence directly. They will give you a scenario and your answer has to be based on that scenario. So if it is a runner, for example, you have to say you don't have to, the runner need not carry multiple devices. Goes that way. Then combined technologies means they share the resources such as battery. So it's easy to charge up as well. The embedded systems, a dedicated system that has one main purpose and all the components are inbuilt. So most of the devices that you have, some electrical circuitry falls under an embedded system, washing machine, microwave oven. So they have their own little bit of ROM maybe to store some instructions. Most of the small systems that you find in a vehicle, cruise control system, anti-lock braking system, fuel injection system, all of them are small chips, small circuitries that are carrying out particular tasks. So features of embedded systems, single function, dedicated hardware, built into a single electronic rather. Dedicated software is there, low power consumption. Small in size, can work in rugged environments, and they try and keep the cost low as well. Then the firmware is also software. So all the embedded systems contain software which we call firmware. Okay, so they are able to do very specific tasks. They will hold the basic input-output system, the BIOS, the bootloader, the hard disk drive or solid-state drive firmware, video BIOS of a graphics card. Gamma currently is going, I think, quite noisy. Give me a second to process. Then firmware is stored in flash ROM of a hardware device, and the types of memory used include ROM, EPROM, flash memory, non-volatile memory, solid state. This is also based on a past paper question. Okay. Then functions of a smart TV firmware, again based on a past paper question, stores the OS, how it starts up, software to interact with the TV's hardware, stores the TV's app, stores the BIOS. So again, so you can see that this particular topic has been tested before. Then assessing the performance of digital devices. Assess means to look into, to compare. I've just given a comparison of a Galaxy S24 versus iPhone 15. The screen size, the processor, amount of RAM available. So you can see that iPhone is coming up with 128 to 512. Even S24 actually has the same amount of internal storage. Apple hasn't said how much memory is there. Camera resolution, the battery power, charging, how much wattage is needed, something that you can compare. Of course, at the end of the day, you will decide to buy a product based on something that cannot be put onto a chart, maybe like something like the brand power, qualitative, what is it, measurement, right? iPhone is known to have a higher brand power than Samsung Galaxy and so on. Okay, right? So that is the first of the slides, only 55 slides there. Then units of storage is the calculation part. So you have to remember that 8 bits make a byte. And in AS level, we are using for storage, we are using the IEC standard. So we have given in the chart at the bottom. 1 KB is made up of 1024 bytes. 1 MIB makes of 1024 KIB. 1 GIB comes in next, and then TIB or TB byte. They don't ask questions beyond TB byte. So you can even go as 2 to the power 10. You are not allowed to use calculators in your AS exam, as in you can't take calculators with you for your IT exam. So they are not expecting you to give the final answer. They are only expecting you to write the expression. So key lesson here is to remember that you have to convert it into the numerator and denominator into a common unit. Okay. Just I read it one more line here. 4 bits is called a nibble. 1 nibble is equal to 4 bits, half a byte. And
I don't think you said it properly in Korean.
when your external conversation can be heard. Then the only formula that you need to remember is data transfer rate or speed of data transfer is equal to amount of data divided by time. Just like the O-level speed equals distance over time formula. And the unit of measure for speed is bits per second or kilobits per second. Simple B refers to bits. If it is capital B, then it is in bytes. Okay, so you have to look at it carefully. Then resolution of a camera, when you say megapixels, that is in multiples of 1000 and not in multiples of 1024. So we did look at this question long time back. 128 GB pen drive, GIB pen drive. One picture is 4 MIB. How many pictures? So simplest term is 128 divided by 4, but 128 is in GIB, 4 is in MIB. So you need to convert the bigger unit into the smaller unit. So we multiply 128 by 1024. You can leave it at that. Movie file of 500 MIB. Internet speed is 10 Mbps. So the file size is in megabyte. The speed is in megabits per second. So that's the first thing you should notice. The common unit you can come to is the bits. Then the formula is rate is data over time. Now the unknown here is time. So time is equal to data over rate. So convert both of them into bits. 500 multiplied by 1024 becomes KIB. Another 1024 becomes bytes. By multiplied by 8 becomes bits. 10 Mbps by 1000 becomes kbps. Another 1000 becomes bps. It's the bottom line there. Not going through it. The rest is the same. Calculation questions. Then you have the number systems, binary to decimal and vice versa. You have learned it in, if you have done local O-levels, maths, you would have learned it in that, or even computer. Cambridge may have had it. So you know a method of doing it. There are 2 ways of doing it. Whichever method is fine. This is just a 1 or 2 marker question. So binary number system 2, decimal, one easy way is to write the 2 to the power starting from the right to the left. 2 to the power 0 is 1. Anything to the power 0 is 1. If you forget that, then that's where your calculation will start to go wrong. Then 2 to the power 1 is 2, 2, 4, 8, 16, 32, 64, 128. You write the powers like that on top. Put the binary number at the bottom. And wherever the ones are, you add them up together. And that will be your decimal equivalent. Okay, decimal equivalent is also called denary equivalent. So just some questions we did. You can try it on your own. So these are the two methods that you can use. Some of you, I remember using the division by 2 method. That's also perfectly fine. Keep on dividing. Only thing, remember, you have to write the number bottom up. And this is something that hasn't been asked at all. Just that sampling is taking, sound is measured in hertz, and sound sampling is the measurement of recording sound. So the sampling rate is how many samples are taken per second. Usually it's 44.1 kilohertz. That sound is measured in decibels, the intensity of sound. So you have 60 decibels is the normal conversation sound. If you were to go to a rock concert front row, that's about 110 decibels. And if you are exposed to anything more than 160 decibels, your eardrums are going to burst. The long topic takes 1 hour. So if you take 1 hour, it takes more than an hour. 6 to 8 hours is enough for you to go through the entire slide set. Okay, so just make sure you go through the slide sets now. You go through them again before, or the first week of May will be your next reference to the material and also the past papers that you have done. So day before the exam, you don't have time to go through all of these notes again. It should be at that point going through the past paper answers. Okay. I know some of you have 2 or 3 papers on the same day, Econ, Maths and IT. Make sure you do give enough time for Math as well, IT as well rather. Maths you give enough time in anyway, no? Then software is the common term given to all computer programs. It breaks down into 2 main types, system software and application software. System software is what is used to control your hardware. Application software is what you use to carry out particular tasks. So the main system software that they are concerned with is the operating system, and it has multiple functions. The key functions that Edexcel is testing are these 4. I've given the diagram, there are multiple functions, but the syllabus is mentioning these 4 functions only. So managing devices, managing processors, managing security, and managing the user. These are the 4 main types of operating system functions that they are asking you. So I have a slide for each one of them. Device management to what is on top is from the textbook, and what is on the yellow box is a mark scheme from one of the past papers, I think. So even device driver is managed by the OS. And any interrupts that happen when you have sent a print job and the printer runs out of paper, a message box will pop up on your screen indicating that the printer has run out of paper. That is called an interrupt. So the operating system only handles that as well. Then process management, managing all the processes that are happening in the computer, especially when you are doing multiple tasks. Okay, then giving enough time for each of the processes, that is done by process management, DOS, creating queues and keeping processes. You have these methods like first come, first serve basis. Shortest job will be done first. I mean, think of simple thing. You are printing, a photocopier guy is printing a book, okay, which is 100 pages. And a person comes in, he just wants to photocopy 1 page of his maybe national ID card or something. So you should be able to, take that job and finish it and send him away. You can't say wait because you came after the other person. Get that person to finish the 100-page job and then doing your one. You should be able to make a decision at that time. Let's do this shortest job first and then do the big job. Of course, that doesn't mean 100 short jobs come and you do all 100 short jobs and delay that person with the 100-page job, So there is a little bit of, you have to use common sense there. I mean, it's easy to remember things like this. How does an operating system schedule tasks? You remember same thing. You are in a queue in a supermarket. You have one, what is it, cart full of goods, 30, 40 items of goods. A person comes running in with just one ice cream in his hand. You should be able to tell him, okay, you go ahead. Okay, because the ice cream will be melted by the time the cashier goes through your cart. That doesn't mean 20 people come in with one item each and you let all of them go through, So there is, you draw a line at some point. Security management, authentication, managing levels of access. Again, think of your Windows operating system. You can set a password at the beginning, pattern lock, biometrics, anything to gain access to your device. Windows provides you with Microsoft Defender, which is a firewall system. You have levels of access that you can set. For example, an administrator can install software, whereas if you are a guest login, you are not allowed to install any software at all. So there's access levels like that. Then user management. Why I've highlighted the bottom 4 in orange is they do seem as if they are, is it the same as some of the functions that were done by the security. That's why I've just highlighted that. I just want to cross-check that whether that can come in here or not. I didn't get the time. Different users to create their own account, creating and deleting users. You can stick with those straightforward answers when when there are questions where two of the same answer is fitting into both the two parts. Avoid answering with the same thing. And Excel is not silly to ask the same answer in two places. So they must be expecting a different answer. So think in that way and write the answer. And in that same point, whenever there's a comparison of any open source or something and all, or try to avoid the cost factor as much as you can. Because cost is a bit tricky. Then Bootstrap Loader, again, there was one past paper MCQ asking you what is the purpose of Bootstrap Loader. So it is carrying out something called the power on self-test. And it locates the operating system. If the OS is located, BIOS will pass control to it. Okay, so that's the Bootstrap Loader or bootloader. Then device drivers are software that are needed to make sure that your computer detects any new hardware such as printers and all. Utility is using for the upkeeping of devices, so antivirus, compression, file managers, backup and disk fragmenters. So anti-malware is also one of them. We talk about anti-malware again in network security. Data compression, reduce the file size so that you can transfer more data at a shorter time. You can utilize your storage better. Run length encoding is one example of a compression method that is used. Just time permitting, go through this. Defragmentation is the process of arranging or rearranging the contents of the hard disk by moving all the segments used by one file into continuous memory locations so that access will be faster. Then different kinds of application software. word processor, spreadsheet, database. You will not get marks if you were to write product names. So avoid writing product names. Then sources of software and copyright types. Free, open source, proprietary, and Creative Commons. If you can't remember these by reading them, please even memorize them, because this is something that is asked a lot. If you forget what they are, I think some of you had forgotten in your exam, school exam, you'll find it difficult. So free, open source, proprietary, and Creative Commons. So free software, okay. So free does not mean it is free in terms of cost. It means it is allowing users to use it. They can, if the source code is available, they can make changes to it. Okay, they can give it to others, no problem. Okay, so free software could be open source or closed software. Audacity, VLC Player, and all are examples of them. And if you have software that is not, you don't have to pay, that is actually called freeware. Okay. Then freeware is price free, but not freedom to modify it. Freeware doesn't mean it's open source. So you have all these WinZip and all evaluation trial software that you can use for years and years without paying. So they can come under that. Then proprietary software is where it's closed software. You can't see the code. You can't have proprietary software and open source software, because if the code is open, people can make changes to it. So they are by default closed software, and they belong to the organization which developed it. Okay, so for example, if you are working at Microsoft and you created a piece of software that does not belong to you, it belongs to Microsoft, because you developed it when you are an employee of Microsoft, where they paid you for the job that you did. Okay, so proprietary software is available only after buying the proper license. It will have proper copyright and licensing. The user can only use the software, and there are conditions for that. Open source code is available. You can study it, make changes, and nearly always provided without a fee. Notice that I did not say that. Okay, without a free. Okay, it can be usually free. That's the point I'm trying to tell you. You cannot put a point and say open source is free, closed software you have to pay. There is a little bit of gray area there, of course. If you were to, you can provide support. You want documentation on how to do it. Software is free, but you don't have time to understand what each of the functions of the software is doing. So that part, maybe somebody has done it and they will sell. Here's the documentation for it. If you want to, I will give that for a fee. So that is where the fee comes in. Or maintenance, that will be costly. Okay, not costly, it will come at a cost rather. Then straight from a past paper mark scheme, advantage of open source. The 2 points in red, that is also from the mark scheme, but I have highlighted them to indicate that usually as a faster update cycle, a better way of wording it is, if it is a popular product, okay, and same thing, if it's a popular product, developers might respond and make changes quickly. If it is a product that only 5 or 10 people are using, you write complaint saying this software needs some changes, no one is going to make the changes for free for you. Okay, so whereas if it's a popular software, these are like, they have their own life kind of thing. Once it is online, it just has its own life, it makes its own path, and people contribute. So LibreOffice, Ubuntu, and all are such popular examples where people who are working in the IT industry, people who are working in Microsoft, Facebook, Oracle, they also contribute to these projects because they make so much of money creating software. They want to give something back to society in a way. So for that reason, I think they join these non-profit ventures. Disadvantage of this thing, support may be expensive. Some of them will have only limited functions. It could be abandoned halfway. And they will mimic commercial products. They're always a copycat rather. GIMP, for example, is a lookalike of Photoshop. And if there's an issue, no one is there to help you as such. Then Creative Commons, it's an organization that provides licenses. There are people, okay, maybe hard to believe in this day and age, who create software and who want others to benefit from it without them gaining any monetary benefit. So they want others to use it, but just because they are not making money doesn't mean they're happy when other people make money off it. So that is where they say you also should use the software for non-commercial. Give credit to the person who originally created it. Don't modify it. If you modify and you are sharing it, share it the same license that the original author created it. Best example is take a song. You have, say, Bhati and Santosh has sung a song. You want to sing that song. They personally have no issues if you were to sing their song and put it on YouTube or anything, or you want to do any new renditions of that song also, they more than welcome it. But certain artists will be very particular about such. You take their song, let's say you take an old classical Sri Lankan song and you make a rap version of it. That person's family may not like it. They may think that person must be turning in their graves listening to this song. So they might file lawsuits against you. So you have to be very careful in when you take other people's material. Just a summary of what we just now spoke about. There's also one called public domain, where you just give away and you don't care what people do with it. They want to use it for, make money even, they don't mind. Then different licensing models. Okay. Software licensing shows the different types of license. You have the single user, multiple user, network, institution, fixed and indefinite. So single user is straightforward. As a single user, you want to get license, you apply and get. Of course, single user does mean it might allow you to install on couple of devices because they recognize that a person may nowadays own 2 or 3 different devices. So if single license is $55, multiple user license, say 3 user license, will not necessarily mean $165. 3 user license may be about $140. So there is a little bit of cost benefit when you buy multiple user licenses. Okay, so that's the other idea. Then network license is for multiple, it's a multi-user kind of license. So you buy it and install on a network. So you have a network of 30 devices, you get network license for 10 devices. At any given time, 10 of your devices can use that software. It doesn't matter which 10. So because there's a license server that will be assigning the keys to 10 of those devices. Then institution license is also known as site license. You get it for your entire organization. It is based on number of people or number of seats. So 20 people means you get a 20 license. And you generally get discounts for non-profit organizations and educational institutes. Fixed term is like subscription. You get a subscription for a certain period of time. You can see that you have different versions, what features you need. For students, again, they'll have better packages. During COVID, they gave better packages for frontline workers, such as hospital staff, policemen, all of them as well. Indefinite is for perpetual license, where you buy a software, you can use it as long as you want. So best example I can think of is you got 2007 Office in 2007 itself. Now it's 18 years since you got it. It's still the license is valid, but that product is kind of ancient now, right? So it might not be that practical using that software. So with that in mind only, most people nowadays buy license in a subscription model only. I know of a student, O-level student, who wanted Adobe Dreamweaver and Photoshop. So what he has done is he has bought a monthly subscription since last month. So for 3-4 months only you will need it. It's cheaper to spend say $10 a month, even that's $40 for 4 months to use that software, rather than spending about $500-600 and buying the software upfront. I don't even know whether nowadays they have certain products don't have fixed term, perpetual license. It's profitable for them to sell you licensing for subscription. This is not something they mentioned in the syllabus, but I have OEM that comes with the original manufacturer. Just go through that. Then updates can be to fix bugs, add new features, improve security. So look at that. To fix any vulnerability, that's a keyword you have to touch up on that. Software upgrades is a newer version of the software. Compatibility issues are there, whether two devices work together, whether one software will work on top of the other. So you speak about that. Finish the slides in a minute.